In my last session, I had presented about benchmark for designing a press tool. I hope you all might have understood clearly. Now, are you ready for the next session? Well, today I'm going to share with you an effective designing and study of economical strip layout. This chapter plays a very important role in designing of a press tool. As it has more content, I have divided into three parts. Today I'm going to share with you all the strip layout part 1. Planning of a strip layout is the first activity of tool designing process. It plays a vital role in effective design of a progressive tool and an economical production of defect-free sheet metal components. Then, how do you define a strip layout? Well, it is a complete pre-plan of designing a press tool, whether it can be a single stage or a progressive stage or even a compound stage. The designed press tool is then manufactured and subjected to the production of component as per the customer's requirement. Now the question is, how does the strip layout control the whole press tool design concept? Well, the strip layout determines the following things: the type of stamping operations required, the sequence of operations required, the number of stations or stages required, and finally, the operations to be performed at each stations or stages. These are the reason the strip layout has a full control over press tool design. There are certain factors that makes you to think of designing a strip layout. The first one is the profile or the shape of a blank or a component. The shape of a component matters a lot when designing a strip layout. For a different shape, a different layouts has to be planned in accordingly, or if there is a piercing or a blanking operations combined, then it has to be subjected to a sequence of number of stages for a press tool for strip layout. So that's how the profile and shape or of a blank influences in designing a strip layout. The second one is the production requirement of the component. The lesser the production, then it leads to a single stage press tools where a strip layout becomes much simpler. But in case of mass production or a high production, then it is advisable to go for a progressive stages, and that's how the strip layout becomes complex according to the number of stages. Even in case of progressive bending, it becomes further complicated, and everything has to be planned in a right way in the designing of a strip layout. The third one is the grain direction of the sheet metal. Generally, the grain direction of the sheet metal does not much matter to other operations, cutting operations, but in case of bending operations, it matters a lot, as the rule says that the grain direction should be perpendicular to the direction of the rolling for an effective bending. Hence, there is a small consideration if the blank is further subjected to non-cutting operation, then the grain direction has to be considered. The next one is the burr side. The burr side is important when the end component is further subjected to in assembly with the other component. Generally, for a normal progressive cutting tool, there will be burr on the both the side of the component. So if there is a specific requirement by a customer that the burr side should be on one side, then that influences the changes in the strip layout. then the material required for the component. So for a different material uh, has to be planned according to the requirement of a component. And sometimes in case of mass production there will be a different length, continuous length of this material, or in case of a small production there might be a clusters of strips, different strips for making as a production in the strip layout. That's how the stock material is also plays an influences in designing of a strip layout. Now, in the profile or the shape of a blank, I generally call it as a blank layout. So blank layout decides the position of the strip and the movement of the strip. In blank layout, the blank can be the blank the blank can be laid in a different position in order to get the maximum stock utilization and a minimum scrap. The blanks generally you see it on the screen here. In the first part you see the blank has been laid in a lengthwise, and in the B you see the same blank is been laid in a widthwise, and in the C you see there is an angular layout. The blank for some component there is an angular layout. So all this layout matters a lot, because to achieve the ultimately to achieve the economical utilization of the stock material. And then further we see here, because of all these different types of layout has been tried on the strip, there is it controls or it has an influence over the position of the strip. We see there are two positions, one is a wide run, other one is a narrow run. And you see that generally the wide run in this design is more preferred, uh, as it has certain reason. The first thing is we see that there is a shorter distance advancement of the strip feed in the wide run, and then we see in the for a given length of the strip as compared to the narrow run, we see that we get more blanks from a wide run. And then in the narrow run, the same component, if it is placed in a narrow run, we see it here on the screen. This is a wide run layout, and then this is a narrow run layout. And in the narrow run, generally this type of layout is preferred for when there is an importance of grain direction, or the component is further subjected for bending operations, and then a grain direction has to be considered. In such cases, generally we can prefer to go for a narrow run. But most of the common way of designing a strip layout is being designed with a wide run. Next one we see here is that the blank layout influences the movement of the strips. Here we see the different movements of the strip, or in other way we call it as a strip feeding. So it can the strip feeding is done in the different types. The one is a single row and a single pass. We see that this single row and single pass is most common way of designing a strip layout. We see that the blanks are being arranged in a single row, and then the strip will pass only once through the tool to produce the component. Or sometimes in a strip you can place uh, two component parallelly, and then it becomes a double row, but the strip again will pass a single pass through the tool to produce a component. But here in the other thing we see the single row and a double pass. Here this is in this design the strip is fed twice. This type of design is done to achieve the more economical of material utilization. But parallelly, it will marginally increase the tool cost. And then we come into the elements of the strip layout. We see it's very important for a tool maker to understand the elements of this all the elements of the strip layout completely. And here on the screen you can see that there is a strip layout, and then you can see a component is been shown here, and then uh, we see the description or the elements has been highlighted here. So these are the very mandatory important elements. Here we see that in the A part we see this is a strip width, the width, and it has to be defined with the right dimensions, strip width. And then in the B we see an arrow mark and then written feed, and this is the feed direction. This shows that strip is being fed in this particular design from left to right. And then in the C it has been shown here that a number of stages and with specific operations, it says here. So here we see the first stage, second stage, three stage. So it is a three-stage strip layout design, and in the first stage a piercing is done, and in the second stage piloting is done, and in the third stage a complete blanking is done. And that's how you see a component is being produced with blanking and piercing operation seen in it here. And then D is the pitch. Here has been shown, it is this pitch is a distance between the two consecutive stations. So as the strip travels from one station to other stations, it will travel with the right pitch, a specified pitch. That's how you have been seeing here the pitch. And then in the E we see the side scrap. These are important as they become the carrier of the strip during the progressive cutting or non-cutting operations. So both the side we see the side scrap, and generally in some designs, some designer they show that being this operator side, they call this as a front scrap and back scrap they call. But in general these two are the side scrap. And then F is the bridge. This is a bridge between the two consecutive components. And that's how we see here the complete elements of the strip layout, which is very mandatory or very necessity when you start designing. All this information has to be provided. So we come to the end of the session here about the effective designing and study of economical strip layout. So I thank you all once again for listening patiently, and in my next session I am going to come up with the economical designing and study of the strip layout part 2. Thank you very much.